Okay, so this is a new lesson for this week, second lesson for week 2. We are now looking at adding and subtracting rational expressions. So we already dealt with multiplying and then dividing. Now we're looking at adding and subtracting. Remember, rational expressions are very similar to fractions. So as we're working through this, think back to how you would add, for example, 1/2 and 3/4. Okay? So there's that reminder, your denominators when you add or subtract fractions have to be the same. Okay, it has to have the exact same number on the denominator in order for you to add or subtract the numerators together. We are going to be using least common multiple very often when we are adding and subtracting these rational expressions. So that's the smallest number that both denominators can go into, or both denominators are factors of. Okay, so for example, if we had 2 and 4, just write this down here. So if you had 2 and 4, your least common multiple would be 4. So that's the smallest number that both of the original two numbers can divide into. Okay, so as we are looking at adding and subtracting rational expressions, we have 4 different steps. You're going to factor every part of the denominator. Okay, we're actually going to do denominator and numerator, so it'll just make it easier. When we go to add them across. Actually, I take that back. We're not going to. You're going to factor both the numerator and the denominator in order to cancel out any factors, but when you add them across, you want to keep them just as numbers by themselves. And you'll see how that looks in a little bit with some examples. So, sorry if that was a little bit confusing. We do factor when we're simplifying them in order to cancel out any factors, but when you're adding across, you just want to focus on the denominator for your factors. Then you're going to get a least common multiple of the denominators. Okay, so the smallest number or smallest factor that both can go into. Make your denominators the same, and then add/subtract the numerators, depending on your operation. Okay, so you might need to reference these steps. I will try to list where those steps are coming into play as we look at some of our examples. Just a reminder, prime numbers have factors of itself and 1. So here are just the first few examples, 2, 3, 5, 7, so on. You can only divide those numbers, so that's what a factor is, two numbers that multiply together. So you can only multiply or divide that original number, so itself, and 1, in order to get one of these here in the list. When you are making a prime factor tree, you're listing all prime numbers that multiply to your original number. So if we have this example 24, okay, we're going to break it down. 8 times 3 is 24. Okay, there are a couple different ways we could have done that. 3 is a prime factor, so I'm going to put a box around it so that I know it's a prime. 8 is not prime, so I can break that down again. 8 is the same as 2 times 4. Okay, 2 is another prime factor. 4 is not, so I'm going to break that down again. 4 is 2 times 2. So my prime factors then are 2, 2, 2, and 3. If I multiply all those prime numbers together, I get 24. Okay, you guys probably did this in upper elementary school or middle school, so it might take a little bit just to kind of remember all of this information, so take some time to practice that if you need. So when we are looking at, this would be example 1, a rational expression, we are going to focus just on our denominators first. Okay, so typically what I do is I would write the denominators over to the side. And then I'm going to list all of the prime numbers that multiply to 12. Okay, so if you need to do that factor tree, you have 2 times 2 times 3. Those are numbers that multiply to 12. I'm going to list out every single variable individually. So I have x times x times x times x, 4 of them, times y. That takes care of my first denominator. Then I'm going to see the second one here. My prime factors of 5, it's just going to be 5 because that's a prime number. Then I'm going to list all of my variables individually. Okay, so right here I have all of my denominators with prime factorization. So I have them all split up. My new denominator, okay, so that means whatever denominator I need to get in order to combine these fractions together. For my new denominator, I need to include every single part of my original two denominators. Okay, so that wording is a little bit tricky, but just kind of pay attention to what I'm going to do. First, going to focus on the numbers. Okay, I start with whichever denominator I wrote first, so whichever one's on top. So I have 2. So when I write it, I'm going to cancel it out. If I can cancel that out from both denominators, you can do that. That's fine. Okay, but I can't cancel that out from both, so it needs to stay 2. Then I have 2 again. Then I have 3. So I've dealt with all my numbers in the top. Now I'm going to see whatever numbers I need for my second denominator, which is 5. Now I'm going to list all of my variables. So again, starting with my top denominator, I have an x. So I can cancel it out in the top. I can also cancel it out from the second one. Okay. Now I'm going to keep going. I have another x. I'm going to write that again. Cancel it out. I can also cancel it out from the second. Still have 2 more x's. I can only cancel those last 2 x's from the first denominator. All right, so now I dealt with all the x's. Now I'm going to deal with the y's. I can cancel that from my first denominator and second denominator. When I do that, every single little component has been dealt with in the first denominator, so I need to finish out whatever's left in the second denominator. So it's y times y. We can only count repeats if they're repeated individual terms between the first and the second denominator. Okay, I can't just count one y because y was repeated three times in the second denominator. I need to include all 3 of those individual ones. So now I'm going to multiply all of these together. So I have 60 x to the 4th. That exponent is how many variables you have, y cubed. This is the denominator that I'm aiming for, or what I need to multiply my original fractions by in order to get 60 x to the 4th y cubed. Okay, so if we go back to our steps were to factor and get a least common denominator. So we don't really need to do anything with factoring. This would be step number 2. Step number 3 then is to multiply both sides in order to get your new denominators to match up. So my first fraction here I'm going to multiply by, so I'm just looking what I need to multiply my denominator by to get it to match up with 60 x to the 4th y cubed. So I need a 5. 5 times 12 gives me 60. I already have all of my x's, so that's fine, and I need a y squared. In algebra, whatever you multiply to the denominator, you have to multiply to the numerator as well. Okay, this is what we call a clever form of 1. If you were to divide that blue fraction by itself, you would just get a value of 1. All right, we're going to look at the second one then, do the same type of process. I need to multiply 5 by 12 in order to get to 60. I need 2 x's, so I need an x squared, and I already have all of my y's. So it's 12x squared. All right, so step number 4, then we're going to multiply those together. Multiply across your numerator and denominator. I have 25y squared over 60 x to the 4th y cubed. When you're multiplying exponents together, you add them. Okay, so I have a y value here of 2 and a y value here of 1. So it becomes a total of 3. My second fraction then is 12x squared over 60 x to the fourth y cubed. Your denominators in step number 4 here should match up. If they don't, then something went wrong with that. Okay, then to finish out step number 4, you're just going to subtract your numerators. I can't cancel out any terms, so it's just going to stay as 25y squared minus 12x squared all over 60x to the fourth y cubed. Okay, I only need to write that denominator once. It'd be the same as saying 3 halves minus 1 half. Okay, you keep the 2 on the denominator and then you just subtract your numerators. And yes, that would actually equal 1, so you can simplify it. Okay, so that's it. That's your final answer that you can do. There's nothing else that you can simplify. Okay, we are going to look at another example, and then you'll probably have to watch the second video for a few more challenging examples. All right, so this one here, again, first step I'm going to do is I'm going to see if I can factor. I can't factor here, so I'm going to list my denominators over to the side. And I'm going to write those denominators in prime factorization. So numbers that multiply to 6 and are prime is 2 and 3. And I have 1a and 1b. For 8, I have 2 times 2 times 2 times a. All right, new denominator. I need a 2, so I can cancel that out. I need another 2, another 2. Okay, I'm jumping between denominators to try to keep the numbers in order. Then I need another 3. Okay, so that takes care of all of my numbers. Then variables, I have an a and a b. So I have 24ab. So for my first fraction, I need to multiply this by just 4. 4 times 6ab will get me to 24ab. My second fraction, I need to multiply by 3b. Okay, now go ahead and multiply across separate fractions. 20 over 24ab minus 21b over 24ab. Again, your denominators in this step should match up. If they don't, then we did something wrong. Now you can go ahead and subtract your numerators. 20 minus 21b. You cannot simplify that because the 20 doesn't have a variable with it. All over 24ab. That's your final answer. There's nothing else you can do with that one. Okay? All right, for this problem, I'm going to kind of give you a step and then I want you to solve it. I will post the answers in a little bit for you guys. So here you have one fraction and you have another number. Here we just have a whole number of 2. So 2 right now as it's written doesn't have a fraction. If it doesn't have a fraction, you can automatically assume it's just over 1. Okay, and the reason why we can do that, 2 divided by 1, that's what a fraction means, is just equal to 2. So 2 is our more simplified way of writing it, but when we're dealing with adding and subtracting rational expressions, we want to make those simplified answers as fractions because it's easier to visualize. Okay, so first thing you're going to do is list all of your denominators. Okay, then I want you to go ahead and try this one on your own. So pause the video here, try it on your own, and then you guys can come back and check your answers to see if you agree. Okay, pause the video. Okay, so you should have gotten this answer as 4 plus 6n over 3n. Okay, 1, the only number that you had was 1. When you multiply anything here by a value of 1, so if I were to include that, it's just going to be that original denominator. So the only thing I needed to multiply was that 2 by 3n in order to get my denominators to match up. Notice too that I canceled out the m in the very beginning. Okay, if you can simplify it anyway, go ahead and do that. All right, you will have to log on to the next video to see a few more challenging problems.